Okay, I'm glad to welcome at our online stage Josh Long, Spring Developer Advocate, who is connecting from California. Good morning, Josh.
Yeah, wonderful today.
Yeah,
Sorry about the
sorry?
sorry about the delay.
Yeah, that's no problem. You know, online experience is a new experience for all of us. So I'm glad to welcome you at Devoxx Ukraine online. We are very thankful to you that you can join our conference. And now the mic is
My pleasure.
yours, so please start your talk.
Okay, thank you. Let me open my presentation. Okay. Okay, you can hear me. Can you see my screen? I think you can. Let's wait for this to load.
We see your screen. Everything works
Perfect.
fine.
Okay. All right. Good morning, everybody. Good afternoon. Good evening. I am sorry about the delay. There's a little bit of a mix-up. My fault. Clearly, I will try and make it up to you. I appreciate that you all came to this wonderful show, and thank you so much for having me. And I thank you for coming to my presentation. Obviously, I know there's other things you could do. It's late in the day right now, so I thank you for being here. Since we don't have a lot of time, and since I don't want to waste your time, I always remind people of this slide. This is the most important, right? This slide contains the coordinates where you can find me if you want to reach me for questions. I am on Twitter. I'm on email, so please don't hesitate to reach out. At Starbucks Man, my direct messages are open. My email is josh@joshlong.com. And of course, my code is at github.com, joshlong, RSocketRevolution. So please find that, take a screenshot of this for later. We're going to go through a lot of stuff right now, but you don't have to follow along right now. Just, use the code for later, right? You can follow that. A little bit about myself. My name is Josh Long. I work on the Spring team. I'm a Kotlin Google developer expert. I'm a Java champion, and of course, I'm a Spring developer advocate. So I've been serving in that last role for more than 10 years now. And as part of that, I've done, I used to travel before this crazy year. I used to travel a fair bit. And I got to see amazing people in the community. And I did some training videos. These are videos that you can buy on Safari that are out there. I have a book called Cloud Native Java that came out in 2017 that I wrote. I have a podcast called A Bootiful Podcast, which is every Friday. That's today. There's a new episode today, of course, every Friday. And so today's episode was with Thomas Risberg. If you've ever used the JDBC template, then you should know Thomas Risberg. And it's fun. And then every Tuesday, I have a blog every Tuesday since January 2011. I've got a blog called This Week in Spring, where I recap all the news that's fit to reprint in the Spring ecosystem. I have, of course, a screencast series every Wednesday, and I have a book that I've just finished writing called Reactive Spring. And this is now out. You can buy it. It's on reactivespring.io. You can buy it on Leanpub or Amazon as Kindle, EPUB, Mobi, PDF, or actual book, printed book. And reactive programming is a big part of what we're going to talk about, but we don't have a lot of time to go into the details. So I'm going to quickly review that. But what we're going to talk about today is something called RSocket. Now, RSocket is a binary protocol that sort of is the logical next step if you understand reactive programming. So hopefully we'll be able to review reactive programming. But what you need to know is that reactive programming is a way of writing software that gives you a solution for three big things. One, how do I write software that is more resource efficient, right? So I can scale better. I can handle more users, more demand. Two, how do I write software that is more resilient? That is to say, it fails correctly. It does the right thing when there's weirdness in the network, right? If there's errors in one service or another, right? And then three, something that gives me a way to write software that's more composable. So if I have service A and service B, and one service speaks WebSockets and the other one speaks service end events, and the other one speaks SQL, and the other one speaks HTTP REST, and the other one speaks whatever, gRPC, and if I want to talk to Kafka or RabbitMQ or whatever, without reactive programming, all of these are different APIs. In the world of reactive programming, there's just one. It's called the publisher. It's called a reactive stream. And if you understand how to use reactive streams, suddenly it's much easier to compose data from different sources together, right? So data from my my WebSockets, my service and events, etc. All that stuff composes very easily now. So reactive programming is very valuable. And in order to do all these things that I've just described, it changes the programming model. It says that when you are dealing with data, you are dealing with data that is not here yet. It will be here eventually. It's asynchronous. And so when you write code with reactive APIs, you're dealing with stuff that is asynchronous. You're saying, I want to do this with this data when the data arrives. Not right now, because it's not here yet, right? I'm describing a pipeline through which data can flow. And so this requires a little bit of rethinking about how you write code. But once you get used to it, it's a very functional style, and it's very easy. So in order to see all of that in action, we need to write some software. Now, obviously, we have many ways we could do this. But today, we're going to do this by going to my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. Now here, we're going to build new software. We're going to build Reactive using RSocket. Now, obviously, there's a lot of good stuff. Most of what we're going to talk about today, in fact, almost all of it, is going to be generally available. It's going to be stuff using 2.3.5, the current generally available released version of Spring Boot, right? But I do want to encourage you to take a moment to explore 2.4.0. You see, there's a lot of other features that we just don't have time for today. Just a lot of stuff that I would love for you to see. There's stuff that's in Spring Boot 2.3 that makes Spring Boot even more relevant, even more natural in the cloud, right? So things like native support for liveness and readiness probes in Kubernetes, things like easy image generation of Docker containers using the Spring Boot Maven plugin, things like graceful shutdown, so that when a pod is killed in Kubernetes, Spring Boot will stop accepting new traffic, wait for the existing traffic to finish, and then shut down, and so on, right? In 2.4, there's two new big features. One is native support for config map as configuration, right? So you can point Spring Boot to config map directly, and it'll just read that from there. And then two, we have support in Spring Boot 2.4 for working with the Spring GraalVM project. Now, the Spring GraalVM project is really nice, right? Like it's we don't have time to go into all this, but it's a good idea for all of your code. It's just a very interesting thing, and it gives you very, very fast, very, very lightweight binary. So here, if I run this application, you can see I've got an application that starts up. What was that? Oh, that's better. You can see my application starts up in 0.13 seconds, right? So, or 0.128 seconds, whatever. Either way, you can see this is an application that has data, right? It has data in it. It's talking to a SQL database. The reason it takes so long is because this actually embeds a SQL database, so that it's starting up a database and it's starting up the application. It's faster if you just connect to another database that already exists. So it's just really, really interesting opportunity, right? You get applications that start up in no time at all. You get applications that take very little memory, tens of megabytes of RAM instead of hundreds. So all of these are very interesting, but we don't have time for all that. But if you try Spring Boot 2.4, you can experiment with all that stuff, okay? So what we're going to do is we're going to build an application today that takes advantage of reactive APIs. We're going to call this a service. and we're going to leave the default version of Spring Boot. We do have some choices down here, friends. We have some choices. There's 3 choices. There's Java 8, 11, and 15. It looks like you have 3 choices, but you don't. You've only got 2 choices, right? 2 choices. Java 11 is the current long-term supported version of Java, and that's okay. It's not great. It's a cowardly version of Java to use. And then there's Java 15. Java 15 is the current supported version of Java. It's not the long-term supported version of Java. So I can choose which Java I want. I will, of course, unless I'm doing GraalVM, I will, of course, choose the current long-term supported version, or the current version, right? So, okay, let's see. Here we go. Okay, use Java. Good. So now I have Java 15 specified. Let's go ahead and select that. Okay, now we're going to use the RSocket support. We're going to use Lombok. We're going to use security. And I think that's it for now. I think that's it. Yeah, okay. So I hit generate. And we're going to go ahead and open up this project in our IDE. Oops, not sure what it's doing. Okay. Come on, go faster. People are waiting. Okay, good. So, public static void main application. I need to set up the JDK 15. Thank you. Okay, there's my application. And so what we're going to do is we're going to build an application that demonstrates, first of all, some basic principles in reactive programming. So before we get too far into Spring, let's just take a brief moment to look at some reactive APIs, okay? In the reactive world, you've got these types called the reactive streams types. So there's 4 types. The first one is called a publisher. A publisher broadcasts data. It publishes it asynchronously to a subscriber. The subscriber, when it first subscribes, is given a subscription. This subscription is super important. We're going to come back to that in just a second. When the publisher sends new records, they are broadcast in the onNext method. When there are errors, they are broadcast in the onError method. And when the processing is done, it's signaled here using the onComplete method. Now, I said that the subscriber gets a subscription, and the subscription is super important. This subscription is what the subscriber uses to ask for more or less data. The subscriber can say, I want to request 10 records or 15 records. And it can also cancel the production of data if it wants, right? So both of these are very convenient, right? This is how the subscriber controls the rate of consumption. The subscriber says, I want only 10 more records, not 1,000, not 1 billion, whatever, right? It's up to the subscriber to decide how much it can handle. And this way, you create more resilient services because you can push back against the producer. You can stop it from overwhelming you, right? This is very useful because it creates stable services in the same way that a message bus in an architecture helps protect a consumer because it allows it to absorb the extra data. That ability to push back, to say, I can't handle this right now, is called back pressure or flow control, right? Very, very useful thing. It's a foundational API. Or reactive streams. This came out of the joint collaboration between the Spring team, Netflix, the Eclipse Foundation, and Lightbend, nay TypeSafe, right? So all these different organizations got together and extracted out these common interfaces. There's a 4th one called a processor. And a processor is a source and a sink, a bridge, a producer and a consumer, right? So let's see. So we've got now those 4 foundational types. They're very useful. They're obviously foundational. They're so useful that they're now in the JDK itself as well. So Java util concurrent, subscription, subscriber, publisher, and processor. And these are very basic types. So we have 2 specialized types that provide rich operators that come from Reactor. Reactor is our library on the Spring team. It helps build on top of the regular foundational types. And so we have 2 specializations, one of which is called a Flux. Flux is a publisher that produces 0 or more records, right? So 0, 1, 2, 5, a billion, 1,000, whatever, infinite, right? There's also a Mono. A Mono is a publisher that produces 0 or 1 record. So 1, 2, 0 or 1, but not 2, 3, 4, 5. Both of these types, both Flux and Mono, have lots and lots and lots of operators. Look at all these operators. Things that we can use to make it easy to consume more or less data. So very, very useful types. And now that we understand that, let's use them. What we want to do is we want to create an RSocket endpoint, an RSocket service. You see, one of the things about RSocket that's so nice is that it's natively reactive. It's a binary protocol that was designed to support our use cases in a production environment. It was originally developed by people who worked at Netflix, who then went to Facebook. And these people knew about HTTP2, they knew about gRPC, they knew about those options, but there were certain things that were still missing. HTTP, for example, has a lot of good things, right? It has a stateful connection, just like RSocket. It has binary data, right? So the payload is no longer text, just like RSocket. But it's still also basically request response, right? That's the first issue. You can use gRPC, but gRPC requires code generation, and everything must be using Google Protocol Buff's IDL, very inflexible, right? So RSocket gets around all that as well. And RSocket goes further by also making it natively reactive. So it's in the wire protocol itself. The protocol gives you a way to say, hey, I am too busy. I can't handle any more data. I'm going to push back. It can apply back pressure in the protocol itself. Remember, from the perspective of HTTP, there's no such thing as back pressure, right? The only thing you can do if you're being given too much data from an HTTP producer is just disconnect. That's all. But wouldn't it be nice just to say, I only want 10 records, then you can process them, and then you ask for another 10 records, and then etc., or 1,000 or whatever, right? And what if you asked for 10, and then you stopped asking for anything for an hour? Wouldn't it be nice if you could just pick up where you left off, right? That's built into RSocket. The other thing that's nice about RSocket is that it's built for production. So if you've ever used Spring Boot, then you know that Spring Boot has a set of management endpoints called the actuator. Actuator gives you information about the services that you've deployed. Things like the health, the uptime, the runtime, the metrics, etc. Wouldn't it be nice if that was a convention for all HTTP services, not just Spring Boot-based ones? Well, in RSocket, it's built into the protocol. There's information about the service health in the service itself, built in. So every service can do this. This makes it much easier. So now that we understand the benefits of Reactive and the benefits of RSocket, let's actually build an endpoint. You see, when the engineers that developed the initial implementation built RSocket, they built the clients for different languages in C++, JavaScript, etc., and in Java. In Java, they used Reactor. So the same Reactor that powers the reactive support in Spring also powers Facebook's RSocket implementations, right, for Java. So we can use it as well. It's very easy to embed in our Spring application. In fact, we even built on top of that low-level integration in Spring Framework to make it even easier. So we can build a controller, so class controller. And what I want to do is I want to build a service that sends a fair amount of data, but I want to do it asynchronously. I want to have a heartbeat. I want to send a new message every second. So I'm going to create a greetings service, okay? And I want this service to send back data of type greeting response, right? So here we are. Private string message at data at RSConstructor, RSConstructor. And given that we get a request, we'll see the response. So private string name. Okay. So given those, I'll say greetings request, and I'm going to return an infinite stream, or not an infinite, we'll just return 100 records. Okay, so from stream.generate new supplier, new greetings response, hello request get name, instance of that now. Okay, so there's our basic stream. I did say I want to limit it. I don't want it to be infinite. It could be, but I don't want it to. I just want to have data. So we'll say delay elements, duration of seconds. We're going to slow down the data. We'll take, let's say, whatever, 10 records. And once we've got this service, what I've done is I've created a stream. It's going to give us just 100 records, and then we're going to see those 100 records one every second. Okay, so there's going to be a little bit of a heartbeat. Just take 10. Now I want to create this as an RSocket endpoint. So greeting controller, and here greeting service at message mapping. Publisher of greetings response, greet. And we'll say greetings request is the required parameter. We'll say this.greetingservice.greet request. Okay, so there we go. There's our existing API. There's our new RSocket endpoint. The only thing we need to do to make this work is we need to configure a port. So we say RSocket server port equals 8888. All right, so there we go. There's our endpoint. Now we can start this up. Look, see how easy this was, by the way? We didn't have to do anything special here to get that to work. It just worked, right? Good, so there's our application. Oh, I should not forget the Spring security dependencies. Let's comment these out for now. Okay. Looks like that's all taken care of. Maven reload project. Okay, so there's our service. Now we can talk to that service using a number of different things. First of all, we could use RSC. RSC is a very convenient command line interface for RSocket. It's like the curl for RSocket. So I can say RSC TCP localhost 8888. We're going to specify a route. The route is greetings. And the type of exchange, the interaction model that we're going to support is a streaming interaction. So we're going to send in one record and we'll get back multiple records. You could also do request response, so one record in, one record out. You could do channel, where you send in multiple records and get back multiple records. And you could also do fire and forget, where you send in one record and you get no records. This is actually a very useful part. I love fire and forget. There are so many different protocols where I don't care about acknowledging the response. I don't need to, I don't have to, and it doesn't help my service if I do, and it just slows everything down. I think about StatsD, right? StatsD is a protocol where you emit metrics, and it's sort of Obviously, it's good if you have every metric, but if you lose a metric here and there, it doesn't matter, right? As long as the service is basically healthy. And so it's a shame that we have to wait for the acknowledgement if you were to use something like HTTP. You don't have to do that with messaging buses, right? You don't have to wait for the response if you don't want to. You can in a lot of cases, but you don't have to. So that's another very useful protocol is to support fire and forget. Just send the data out, broadcast it to whoever wants it, but move on because you don't have time to wait. Okay, so there's the data. And the data that we're going to send in is, and by the way, we can do content negotiation. So I'm going to do name Devoxx. Okay, whoops, no handler for greetings. Whoops, greetings, silly me. Compiling. There we go. There's our data. One record every second. Okay, so we've got some asynchronous data. Now, of course, that's one way to get the data. Another way to get the data that I really like is to actually build an integration pipeline, right? So I'm showing you how to use the service from a command line, but a lot of times when people are using something like RSocket, they want to integrate with the rest of the ecosystem. One of the nice things about reactive programming is that if you are in an all reactive environment, everything is reactive. Your database, if you're using something like R2DBC, then it's reactive. If you're using something like Spring Web Flux, it's reactive for service socket events and service and events and WebSockets and all that. That's wonderful. But sometimes people want to integrate, right? They want to take non-reactive and reactive things and mix them together. And so for this, we have Spring integration, right? Spring integration is a framework for building integration flows. So I'm going to bring in Spring integration, and I'm going to bring in an RSocket. We're going to call this integration. And we'll hit generate. Now, Spring integration is a pipes and filters messaging technology. It's an enterprise application integration framework. Okay, it's been around for a long time. It's not only reactive. You can use it to write code that talks to anything really. I mean, you can talk to file systems. You can talk to JMS. You can talk to Kafka, RabbitMQ. I mean, all sorts of different things, even if they are not reactive, right? And so it'll help you write very easy glue code to make these things work together, right? So what I'm going to do is I'm going to use Spring Integration's file support, and I'll use their RSocket support, okay? Okay, so I'm just the two different dependencies here. Good. Good, good, good. So there's this. Now, what was that? Oh, okay. Okay, so what we're going to do is we're going to build a Spring integration bean that responds to any issues. Okay, sorry, forgive me, friends. So what we want to do is we're going to build an application that responds to changes in a local file system, and we're going to do that by, first of all, creating an integration flow. So an integration flow is just a way to describe a pipeline. This technology borrows from the patterns from the amazing book called Enterprise Integration Patterns by Gregor Hope and Bobby Wolf. Okay, so great book if you get a chance. This framework supports these patterns, and so we create an integration flow to describe how data connects together. We do that by describing how data comes into the system, where it's originating from, and we describe the transformations on the data, and we describe the destination for the data, the output of the data. So what I'm going to do is I'm going to create a pipeline where I read data from a file inbound adapter. Okay, so the first thing I want to do is I want to take a regular thing like a file system. file inbound adapter equals files inbound adapter. I'm going to create a new file here. File, new file. I'm going to inject a reference here to the home directory. Home, okay. Desktop file. Okay, and new directory will be actually here, let's just do that in. Okay, so we're going to say whenever data comes in to that directory then we want to make sure that the directory gets created. We're going to use this inbound adapter here. So we'll say file inbound adapter. And remember, file systems don't tell us when something has changed. So we have to poll. We have to constantly re-ask the question. And we can do that by specifying a poller. So p.poller pm dot fixed rate 1000 milliseconds, 1 second. And once the data comes in, it's going to give us we can chain together transformation. So I can provide another operator here that it provides a transformer, a spring integration transformer. And here I can read the current message that I'm being given from the inbound adapter. I can take the message, do some work on it, and return another message. This is a Spring Framework message, okay? It's in Spring Framework itself. So you have headers, and you have a payload. This is the basis of the integration patterns, is I have the ability to do lots of little transformations like this. This is kind of like reactive programming, right? So it's very convenient, very natural. And what I want to do is I want to take this message, I want to get the payload, and I know that the result is a file because I know that the output of the inbound adapter is a file, right? So I could do that if I wanted, but what I want to do is I want to take the data and turn it into a string. I want to read the data from the file and just convert it into a string. So in this case, the thing I'm going to have from the file will be a name. Once I've done that, I want to transform it again. So remember, the output of this is a string, right? So I have a string now. So I want to take that string here as the input of the next thing and turn it into a new greetings request. So I'm going to go back to my code and adapt these types. Okay. Okay, so I need to add Lombok again. Okay, so come on. Okay, from there, greetings request, new. Okay, so I'm transforming it from a string to a greetings request. And then I want to send that string. No, actually, I want to take that string. I want to transform it first. One more time. String class s.trim. String it, and then I'm going to send it. I'm going to send it here as a greetings request, and then I'm going to send it out to my RSocket endpoint. So I've got a message coming in from the file system. I'm going to send the message out to my RSocket service using something called a gateway. Now, usually when you adapt data, the data comes in and you take it from the outside world and you turn it into a framework message, or you can take a framework message and send it out to the outside world. So one message in, one message out, but it's one direction, right? With a gateway, the message comes in, you transform it, produce a response, and send a response back out. So gateway is in and out, or it's out and in. So it comes in from the outside, it gives you a response, and then you respond backwards, right? So I want to create an RSocket gateway to make a request of our RSocket endpoint, right? I'll use the RSocket gateway here. RSocket, come on, RSocket, outbound gateway. RSocket, is this not here? There it is. Okay, good. So it's here. So our sockets. Outbound gateway, greetings. Right? Let's see here. Is this not compiling? I am very confused. Integration DSL. Okay, let's go up here and see what we got. Spring integration RSocket. Is this not real? It's right there. So why? Org Spring Framework integration. Yeah, that looks right. So let's see here. Maybe I just delete the local one. Org Spring Framework integration. Spring integration RSocket. When in doubt, flush it out. Okay, good. Maven reload. Compilation failure. Yeah, I get it. Okay, let's see. What's the issue now, I wonder? Expected a semicolon. Of course. Now. Okay, don't care about that. Okay. Now, RSockets. Maven integration. RSocket. Integration RSocket DSL. RSockets. Integration RSocket DSL. Feels like that should be there, right? I think we can agree. Let's see. Maven re-import. Spring integration RSocket. There's this. What is happening? Okay, we're going to try this again. Something is very strange about this. Maven reload projects. See if that compiles, even if it doesn't work in IntelliJ. Okay, there we go. See, it does compile. That's weird. Okay, so it's IntelliJ that's having the issue. IntelliJ doesn't think that library exists for some reason. So we close it and we start again. Spring integration, RMRF target, RMRF integration.iml, RMRF.idea, idea pom.xml, etc. Okay. up the SDK. There it is. There it is. What is that about? Do you understand? That was so weird. Okay, so we got it. Get rid of that. Return this. Good. We'll come back to this in a second. Okay, that's good for now, but we'll come back. And this and that. There we go. Okay, there's our outbound gateway. And so the outbound gateway is going to it's going to send a request to the RSocket service that we've already got running on port 8888. In order to do that, we need to create some way for the service, the client rather, to connect to that. So we use a client RSocket connector. So var crc client RSocket connector, localhost 8888, crc.setRequest strategies, and here we're going to inject the RSocket strategies. Okay, we'll say strategies, return crc, and then crc dot, and actually that's it. I think that's all we need. So that's going to describe how to connect to that service. We can inject this here, crc, and we provide that as the outbound bit there. So crc, and then finally we want to connect. We want to describe the streaming type. So remember I told you about the interaction model. So RSocket interaction model dot streaming, right? Request stream. And then finally, we want to describe what kind of data we want back. So we want a greetings response, right? So greetings response dot class. Okay. Oh, interaction model. There we go. So there's our basic interaction, our pipeline there. So we're going to say, okay, handle the message by sending it to the RSocket outbound gateway. Now the data that comes back might be, there's going to be multiple records, and I don't want to process, like if I wrote code at this point right here to transform the result, for example, I would say new transformer, and the data that I would get here from each message in this case would be a publisher of greetings response, right? So I'd have to cast that to a publisher of greetings response, and I would get back the payload, and that would be the right type. But I don't want a publisher of each one. I want just a single greetings response. I want to have a different message flow for each one. So what I'll do is I'll split. Okay, I'll split the data, and what that gives me is now I've got each new message has only a greetings response, not a stream of greetings response. The problem is, of course, that once I've split the data, I'm on this side for this component. I need to deal with back pressure, right? I might have too much. I need to be able to push back. And so we want some way to communicate back pressure. And one way you can do that is to use a flux message channel. So behind the scenes, Spring integration uses something called a channel to separate messaging components from one another. And you don't normally need to worry about it unless you want to. It's a great way to explicitly say this component communicates to a message channel, and that decouples one integration flow from the other one, right? So I can use that here. I can say channel, and now I have back pressure built in, and now I can actually just process the data. I can actually say, okay, I want to handle the results just to log something out, right? Generic handler. And the data that I'm getting here is a greetings response. Okay. Good. Good. So I can process the data. I can say, okay, system out new message o dot toString, etc. Okay, so I'm just logging out the results, and there's my integration flow. Run this. And so we create a file, echo Devoxx desktop in hello. There you go. Hello Devoxx every second, right? So that's an integration flow using regular reactive things and showing you how you can adapt them to work with something as awesome as RSocket. This is just one way. There's lots of other things you can do. Now this is great for if you have some other stuff you want to connect to. But if you just have a regular service and you want to connect to an RSocket endpoint, then of course you can go and create a client. right? So we'll do that as well. We'll create RSocket security Lombok. I'm going to hit generate, and we'll do UAO client.zip, CD client, Maven installed. Everything's there. Okay, so now we have a client, and what we want to do is we want to talk to our application. So we create an RSocketRequester. This is the native non-blocking reactive client that we can use to talk to that endpoint. So RSocketRequester builder. Okay, and notice that when you create a client, you connect at one time, right? When the application starts up, you connect at the very beginning of the life cycle of the application. RSocket services, once they start up, they can connect to each other. They're not client and service. They're a requester responder, right? A requester can ask a responder for information. But the thing that's interesting in RSocket is that that responder can also be a requester. Both sides can ask questions of either side at any time. It doesn't matter who first connected to who. The other one can make the request. So here, RSocketRequester, and I want to actually create a little bean to listen for that data. I'll say application ready and RSocketRequester. I'm going to log the result out. I'll say dot route greetings. And I want to get the data, right? I want to send the data that I'm expecting to come back. I'll say I want a stream of greetings responses. We'll go to the service, get all this stuff here. Paste. Okay, so I'm going to say I'm expecting to send some data in. The data I'm sending in is a new greetings request, Devoxx, right? And I expect a stream of responses back, and I'm going to log out those results. Okay, so system out print line, and voila. Okay, there's this. Now, run this if I want. Oops. One of the things is that the application is asynchronous, right? I'm starting up the connection, I'm making the request, and there's nothing to keep the socket open because it's not an RSocket server, it's a client in this case. There's no process serving anything yet. So I need to keep the thread open by squatting on system in. Okay, so there you go. You can see we're getting the records back one by one from the service downstream. And that's great, right? That's exactly what we wanted. So now we have a very simple interaction model. You can see we create the RSocketRequester. Once the application starts up, it connects. It stays connected. That's a benefit because it means you're not constantly reconnecting each time. It's very efficient this way. I'm using the RSocketRequester. I like the RSocketRequester. But some people asked about, would it be possible to have a more RPC style model, right? So I actually went out and built one. That you can try. It's experimental. It's definitely not GA, but it works. Maybe you appreciate this. So here's how you get started. It's called RetroSocket. Okay, and you can easily add it to your code base. You just pick the version of the dependency here. And the version, of course, is 001 snapshot. It's GA, not yet finished, not real. Add the snapshot repository. So I'm going to add that here. Okay. Maven, reimport. Hopefully this doesn't go worse than last time. Let's first do the build. Maven install. Okay, so now Maven reload. Okay, and now what I'm going to do is I'm going to describe an RPC-like experience for that service. I'll say this is OpenFeign or retrofit, right? So it'll be a greetings client, RSocket client. Okay, and then publisher of greetings response, greetings request. There you go. So there's that. I'm going to do message mapping, greetings. Okay, so this is my client. I need to enable RSocket clients. Okay. And now I can build another client. I can actually just build another bean to listen to that. And this will be this is a RSocketRequester listener. And this will be RetroSocket listener. Okay, so here, I just need to inject that interface. There's no code required really, right? So I'm just going to say greetings client dot greet new greetings request Devoxx from RetroSocket dot subscribe system out print line. Cool, right? We got the experience now, so we can run this. Let's comment this one out so we don't get redundant data. Okay, there you go. So that's working as well, right? So either way works just fine. The problem with Spring RetroSocket, even though I like it, the problem is that it is a client that's built in, right? It's for RPC. It's for acting as a client to a service. But remember what I said before. RSocket endpoints aren't necessarily client or service. They can be bidirectional. And that's really powerful if you think about it, right? Because that gives you the ability to write a service that asks questions of the client. The client, in turn, is its own kind of service. And so what we're going to do is we're going to take a look at how to use that functionality to expose information from the client that the service can use in determining what to do next. So what I'm going to do is I'm going to create a simple endpoint here. Okay, let's say that my service, let's say that my client rather, has some health data, some telemetry data, something like that, right? That tells the service whether it's healthy or not. And if it's healthy, then the service will keep giving us data. If it's not healthy, it'll cancel, right? We'll say data, all args, no args, instructor. Okay, so it's like a heartbeat. So I'll say health controller, message mapping, health, publisher of client health state. Okay. Return publisher of new supplier. Return new client health state. Okay. Math.random greater than 0.5. So we're randomly determining whether we're healthy or not. Okay. So there's that. The elements. I'll say get a new record every second. Okay. And there's my controller. And the benefit there is I want to create that controller and expose it to the service, so the service can ask me as a client once I've connected for information. Okay. In order to do that, I need to configure my RSocketRequester a little bit here. So I've got my RSocketRequester. I need to configure a bean, socket acceptor, and in order to do that, I'll create a RSocket message handler responder client. Okay, so we'll say RSocket strategies, and then I'm going to return the client health controller, right? The health controller. Good. So there's my socket acceptor. I can inject this here. Okay. And we actually can just configure it. Sorry, wrong side. Over here. Okay, so we're gonna configure this. There you go. So now we're actually, when the client connects, it will say to the service, hey service, I can also answer questions if you send a message to my health endpoint. Okay, so now it's bidirectional. So now what I want to do is I want to take that data here, and this is an example where we can use the really, the bidirectional capabilities, or we can say on the service side that you want to inject the client socket, okay, client socket, and then we want to ask it questions, right? And I can do that. I can say, okay, health, and what that gets me is a stream of health information, right? So I get this, take that, Command C, place that there. So I'm going to call the service, the health service, and once I've got the service, I want to get back a stream of client health state class, and then I want to filter it. I want to say, okay, if I get a certain kind of data, then I want to send back. If I get back information that says that the client is healthy, then I want to continue sending more greetings. But if it's not healthy, there's no need to send more greetings, right? The 10 greetings or whatever. And this is very common. You have like a video game where if the client disconnects, there's no reason to keep sending data back and forth from the server because it's a waste of resources, right? And so we can actually describe that kind of flow here pretty easily. We can say client socket.route retrieve flux. And we want to filter the data, CHS. CHS is healthy. So basically, this will give us a stream of client health objects. But we don't want all of the health, because if there is no problem, then we don't care. Everything is fine. We want to filter it. We want to drop all the messages, all the responses that are healthy. If they're healthy, then no problem. Don't worry about it. But if they're not healthy, then we want to keep it. So for most of the life of the application, health is going to be empty, right? But as soon as it's not empty, as soon as there's one record, then I want to stop producing the response, okay? So I say, there's my greetings, my response. And what I want to do is I want to say return response take until other health, right? So this gives me a way to say keep producing this stream as long as this is empty. As soon as it's empty, though, don't send more data, okay? So an example of I'm injecting the client's socket. I'm using the client socket to ask questions. I'm going to use that information to determine how I respond in the service. So it's a conversation. The state of one thing, what I'm doing over here on the client, affects what's happening here on the service. Isn't that cool? So let's go ahead and run this. There you go. Looks like we got 3 records in, and then we ran into a bad health. It stopped sending the data. My friends, we've just looked at the very beginnings of RSocket. We've looked at reactive programming. We've looked at integration. We've looked at different ways to do clients, including RSC, including RetroSocket, including the RSocketRequester. And we also looked at one of the most powerful features, which is the ability to do bidirectional communication. We also saw, thanks to reactive APIs like Flux, that we have this very easy ability to compose different reactive streams, right? So I'm dealing with publishers all the way around. Everything I've showed you so far, except for the Spring GraalVM native support back in the very beginning of the talk, is already GA, so you can try this out and so on. Unfortunately, looks like we didn't have enough time to cover Spring Security and RSocket, but it's really nice. You can use JWT tokens, or you can do something like a username and password based very easily. So you can encrypt, you can secure your RSocket streams. We've only begun to look at RSocket. RSocket is the first project that the Spring team and Lightbend and Facebook and Alibaba and others, it's the first project that we all donated to the Reactive Foundation. We're all founding members of the Reactive Foundation. So all of us have gotten together and we are working on RSocket, all these different organizations. I spend a lot of time traveling from one place to another. I used to be before this year. I would go and spend several days, maybe a week in China with Alibaba. Every year, I would talk to them about different things. I'd say, "Oh, look, back in 2014, I'd say, look, we have this thing called Spring Boot. You will like it, right?" And then they tried it out, and of course they were already using Spring, so they loved Spring Boot. And then I showed them Spring Cloud, and then I showed them all the sort of new stuff, and then reactive programming. And then 3 years ago, I finally got to show them RSocket. Now RSocket is becoming an organizational standard, right? And so they're heavily invested in this use for their applications. It allows them to go faster. They even built a broker, but they're not the only ones. We also built a broker. And the idea behind the broker is pretty simple. Imagine if you have a broker where requests come into the broker, and then the clients, they connect to the broker, the clients stay connected, and the broker can act as a hub. Other services contact the hub. The hub has all the different live client connections from all the other services, and it says, oh, your health is very good. You can handle this, and it load balances the request to that socket that it's got, right? The best part about this, of course, is that since there's bidirectional communication, all the clients that connect to the hub, they can be completely black box, right? They don't have to have open IP firewall rules. They can have no ingress, no inbound requests. That's easy, right? It's very secure that way. They stay connected. The clients connect to the hub. They stay connected. The hub gets data from the outside world, from HTTP or something. It transforms the request, load balances it to a particular service. If there are no instances of the service, because we have session resumption and we have true back pressure, the hub can apply back pressure to the client, wait for something to come online, and as soon as it comes online, it doesn't apply back pressure. It forwards the request to the downstream service. So there's some really amazing possibilities here with this broker that we're all working on together. I hope you'll investigate. I hope you'll get a chance to try it out. You're certainly not alone. Everything I've showed you here for RSocket, except for RetroSocket, is GA. So this is in Spring Framework. It's in Spring Boot, in Spring Security, Spring Integration, etc. Right? It's all over the place. Thank you so much for your time. I hope that you're all healthy, happy, and safe. And as always, I encourage you to find me online, josh@joshlong.com, or at Starbucksman.
Thank you, Josh. Thank you very much for connecting this morning from California and conducting this talk. Dear participants, you can join the Q&A Zoom room with Josh and ask your questions. Maybe you will even have some time to discuss the security in Spring, the topic that we didn't have time to cover right now. But again, I'm very thankful to you for supporting Devoxx Ukraine online. Stay safe, stay healthy, and hope we see each other next year.
Me too.
Thank you.